Welcome to the module. Today we're going to introduce Java Enterprise Edition, looking at the web tier and particularly JSF. Although we'll be talking about Java Enterprise Edition, the principles behind the concepts will be equally applicable to all kinds of other enterprise applications in different types of languages. So as we go through this module, please look out for those principles that underlie the enterprise applications that we'll be talking about in Java. Now, an enterprise application is a large-scale, multi-tiered, scalable, reliable and secure network application. Now that sounds pretty complicated, and indeed it is. Enterprise applications tend to be very large, with all kinds of applications that interact with each other. And therefore, we need some kind of framework to facilitate the interaction between these sometimes disparate and non-homogeneous applications. Now, the benefits of an enterprise application are great for large companies that have got huge numbers of applications. Some of them are legacy applications, some are brand new, and they all have to interact to further the cause of the business. But those same benefits are equally applicable to individual developers and small organizations, because we're in an increasingly networked world, and therefore our small applications could be interacting with other people's applications, particularly via, for example, web services. Now, the features that make enterprise applications powerful, things like security and reliability, also mean that these applications are complex. And we've got two ways of dealing with this complexity. One way is to build our own underlying software that implements all of this complexity. Another way would be to make use of a framework that has been built to deal with all of these complex things. And all we've got to do then is to write our own functionality and drop it into the software that implements the framework. And that's what the Java Enterprise Edition does for us. It provides an enterprise application framework. It provides an API and a runtime environment that will allow us to develop these enterprise applications. And it solves many of the large problems, and indeed the lesser problems, and provides the software that deals with all the complexity of things like security and reliability and scalability. And so what it does is provide the developer with productivity gains that allow the developer to forget these underlying complexities and to focus much more upon the functionality of the application that they want to develop. Now, the framework provided by Java Enterprise Edition is a multi-tiered distributed application model. It is component-based. Now, that's a good thing because it means that we can write our components and plug them into the framework, use them, and when we want to replace them, we can unplug them and put in a new component in their place. But it also is a good model for development because it means that we're able to keep in a localized area problems. So if an error occurs in one component, it should stay localized to that component and not really propagate through lots of other components. It also means that as we're extending the functionality, if we need to change one component, then the changes should stay localized within that component and not propagate to other components. The Enterprise Edition version of Java also provides a unified security model, as well as flexible transactional control, which means that we are able, within our application, to define a transaction that must consist of many operations, but those operations will be considered atomic. Therefore, all of them occur or none of them do. And if an error occurs in any one of those operations, we can roll back the transaction so that the entire system is exactly as it was before we started the set of operations. It also provides support for web services and is an open systems development environment. In other words, it's not tied to one vendor. The Java Enterprise Edition specification defines what a vendor must provide, and so we can use one vendor's application for development and then put our components into the framework, the Java EE framework of another vendor, and they should work in exactly the same way because both vendors will have implemented the framework according to the one specification. So generally what we have is a three-tier system. client tier, application server tier, and enterprise information tier. The enterprise information tier is possibly implemented as a database, but it might be all kinds of different databases. We might have some relational databases, as well as maybe a NoSQL database, and maybe an object-oriented database. And in the mix of all of that, we might also have other applications that, perhaps via an API of some sort, provide data from their area of the world. And so this information that the enterprise uses could come from a variety of sources. And one of the things that the Java Enterprise Edition platform provides is a way of treating these different sources of data in a more uniform manner. In other words, applying the software engineering concept of separation of concerns and separating the access and the maintenance of that data from the business code. Now, the business code is embodied in the application server. We have two subdivisions. One subdivision is the interaction with clients, and you can see in this diagram here that things like servlets and Java server pages and Java server faces will provide that functionality. And on the right-hand side of that diagram, you can see Enterprise Java Beans. This is where the business logic is held and implemented. All the rules that define the business, these are held and implemented in the Enterprise Java Beans. And on the client tier, we'll expect to find things like web browsers and applications that will interact with the application server. So what we do is write components, which are self-contained functional software units that can be dropped into the framework at the appropriate place. Some components will execute on the client, and some components run on the server. Things like Java server faces. JSP has now been deprecated. There are still many systems that use it, but we'll focus on JSF in this module. And other components such as the EJBs, Enterprise Java Beans, these are the business components, and we drop those into the application server tier. Some of the client tier components might include applets, although that is likely to be less common these days, especially since web browser providers are now dropping the Java plugin that is required for applets in favor of making use or asking developers to make use of the Java Web Start environment, which is a framework that allows us to hold Java applications on the web server and then at the click of a button on a web browser distribute that application to the client, and then it will execute on the client as if it were an installed desktop application. This allows us to provide much richer interfaces than might otherwise be available via the web browser. And so these application clients will typically have a graphical user interface that will be written in Swing or some other graphical API, and will be distributed using the Java Web Start framework. Now, Java server pages are text-based documents that when compiled will end up as servlets. And so essentially JSPs and servlets are equivalent. Java server faces is a very different framework, and we'll be focusing on that in this module. They will run in the application server tier and will be the point of entry for clients that want to have some kind of web-based interface. We can also make use of Java Beans within our applications. These are POJOs, plain old Java objects, that have properties, that is, a field with corresponding get and set methods. Now, these are not considered part of the Java Enterprise Edition framework. On the other hand, we do have within that framework Enterprise Java Beans. And these are components that we write that will implement the logic that meets the needs of that business domain. So those tiers will look a little bit like this. You can see on the left in the client tier the various kinds of applications that would execute on the client machine. Within the server, we've got the web tier and the business tier. We will, in this lecture and the next lecture, consider some of the web tier, which might very well contain some ordinary Java Beans. And then also in the business tier, we'll focus a lot on that over the course of the coming weeks. There'll be entity classes that help us to interact with the enterprise information tier, session beans and message-driven beans, both of which are to do with implementing the business rules. Those various components are held within containers. If you've written Java server pages, servlets or JSF before, then you'll be familiar with the concept of the web container. The web container is a piece of software that is a framework into which we drop these web components, and those components are managed by the web container. We have exactly the same concept with the EJB container, and this is where we're dropping the enterprise Java beans, and it again will manage the life cycle of those enterprise Java beans. So a container is a runtime service and provides the interface between the components and the low-level functionality within the framework that it supports. Now we're going to use Oracle's Glassfish server as our Java EE container. It ships with NetBeans. Therefore, if you install the right version of NetBeans, and I recommend that when you go to netbeans.org to download NetBeans, that you select the rightmost option labeled All. It's the biggest of the downloads, but it will provide you with absolutely everything that you need, and it will include this Glassfish server. Now, as I mentioned a bit earlier, we're going to focus on JSF, Java Server Faces, and it's a framework with a distinctive request-response lifecycle. And so we'll focus on that now. This lifecycle consists of a controller with some managed beans and some views. The controller is indeed a standard servlet that's provided by the JSF framework, and so we never have any control over it. What you can see on screen here is the controller servlet that will cause some kind of update to occur within some managed bean. Sometimes these managed beans are called backing beans, and they are beans whose properties are linked or bound to elements within a view, so that the backing bean, the managed bean, will provide data for the views as they are being rendered. Also, if there's a form in that view, the backing bean will receive the values that have been typed by the user and submitted with the request. So I'm just going to explain a little bit about this life cycle. We'll give a little bit more information as time goes on, but this is a fairly quick overview for now. So we have the request that comes in to the control servlet, which is on the left-hand side of this diagram. The control servlet is going to take the values, the form data that arrives as parameters on the request, and put it into the managed bean. But it doesn't do it directly. The first thing it does is to build a component tree that represents the view. Let's call this view 1, V1. Now, if this has got form data on it, then that view will contain a form. Let's say it's got 2 text boxes and a submit button. That means this form has got 3 components: TB1, TB2, and a command button. The values that are provided by the client will then be entered into these components in the component tree. So let's assume that the user typed A in the first text box, B in the second text box, and that the command button has got the label send. So you can see on this diagram that the control servlet will have built this component tree and populated those elements with the values that have come in from the client via the request. The next thing that the control servlet does is to convert those values into the appropriate data type. Because HTTP is a string-based protocol, all of the values, whether or not they represent integers or booleans or whatever it might be, always arrive as strings. And so the control servlet will take those strings and attempt to convert them into values of the appropriate data type. If the conversion fails, the control servlet halts its processing and returns an error message to the client. If the conversions work, validation will be attempted by the control servlet. Those validation rules will in part, or perhaps mostly, be defined by our application, and we'll talk about that at a different time. If the validation fails, again an error message is sent back to the client. If the conversion works and the validation is successful, at that point the values are copied from the component tree into the managed bean. So let's assume that we've got a variable a, lowercase, and a variable b, lowercase. Those are the fields within the managed bean, and there will be set and get methods for each of those fields, rendering a and b as properties within the managed bean. And so we'll end up with the values uppercase a and b being copied into the managed bean. This means that we are guaranteed that when the managed bean has received its values, they will be of the correct data type and will have been validated. And therefore we can go ahead and process these values in some kind of appropriate way. Now, in the example that we shall see a bit later, that means that there will be some method within the managed bean that is executed when the send button has been clicked. That might very well interact with the database. So it could use, for example, the values A and B to query the database, extract further information that is stored in other properties within this managed bean, and then those values that have been fetched from the database can be displayed on the output view. So the next thing that the control servlet will do is to prepare to output a response. That means that it's going to take the view that it's about to render and build a second component tree. This we'll call view 2, which is the output view. And perhaps there are two output components. It doesn't really matter what they're called. Let's call them X and Y. And those components in the component tree will receive their values from the managed bean, because the control servlet will call the get methods for those properties in the bean and take the values that come from calling the get methods and put them into the component tree. So I'm just going to put in here, I'm just going to put in A and B again by way of example. Then finally the control servlet will output the view v2, which will be an XHTML file, take the values from that component tree and output the response. And that essentially is the life cycle that is imposed by the JSF control servlet. You need to become familiar with that life cycle because it will underpin everything that you do in the web tier when using JSF. So by way of recap, the control servlet is a standard JSF servlet. We have no control over it. For a given HTTP request, it's going to generate a tree of components, populate that tree with request parameters, and maybe the previous state, perform conversions and validation, then update the managed bean with values from that component tree, and maybe do some other processing, and then prepare a component tree for the output view, copying values from the managed bean into the component tree, and then using that component tree to render the next view, and then save state if necessary. So let's take a look at an example. You can find this on Blackboard. Let's start off in index.xhtml. You can see that this starts off with an HTML tag, within which are some XML namespace definitions. The first one is required so that we can make use of the XHTML environment. The next one is required so that we can access the predefined HTML tags. And we have here the definition of a label. So this namespace in this document will be referred to by the label H. And you can see an example here. So H is used as a prefix to the element name so that the renderer can know which of these libraries to look in for the body tag. There's another namespace here which is called facelets and has been given the label UI. Now, very often, we will want our applications to have a common look and feel, a common layout. So in template.xhtml, we've defined that standard layout, which here consists of a header, and within the body, a graphical image, followed by some kind of content. Now, this is a UI insert element that's been given the name content. When we access some kind of facelet, now a facelet is a file with a .xhtml extension. So in a facelet such as index.xhtml, we'll find a tag called composition, where the template for that composition is defined in the file that we've set up here. So it will always have that head, it will always have this graphical image. And what we're going to do next is to define an element called content, which will match the name of the insert here. So whatever is defined in here as content will be inserted into this layout at this point. Now we find here a form tag, and within the form we've got all kinds of things. I'm going to highlight only a couple of things. If ever you want to output some value, in this example a literal value, then you can use the HOutputText element. Now the nice thing about XHTML is that it will render this output in a way that is appropriate for the device or the client that is being interacted with. For example, an input text in web browsers will very often be rendered as a text box, but the way that text box is displayed will depend somewhat upon how the web browser provider has decided to implement it. It will have a slightly different look and feel from one web browser to the next. And in a mobile device such as a smartphone, it will have a different look again. With this input text, what we're doing with the value attribute is binding the value to a particular property in a managed bean. We'll talk about those in a minute, but simply putting in this hash, open brace, then the managed bean name dot property name, close brace, within the double quotes of the value, that binds this input field to that property in the managed bean. So whatever the user types in the text box will, via the life cycle that we talked about a little bit earlier, will end up inside the property of that managed bean. It's also possible to use the value equals and then binding to a property in a managed bean for output texts. So instead of displaying a literal value, it's possible to display the current content of a property in a managed bean. So this depths managed bean is defined in this package here, and as you can see is pretty well a standard Java class. What makes this a managed bean is this annotation here. By putting in @named, we immediately make this Pojo a managed bean, and therefore the JSF control servlet will decide when to create an instance of this class, interact with it, and then at some point will delete that instance. Now, just how soon it will be deleted depends on its scope. In this example, this is a session-scoped managed bean. We can tell that from the annotation here. And that means that the instance that is created on the first interaction from a particular client will stay in existence for as long as the session does. We can see various fields here that will become properties, and there are corresponding get and set methods down here. When we say this input text field here is bound to the username property, because we're wanting to take this value, whatever the user types, and put it into this bean, then the set username method will be called. That parameter will be passed containing the value that was typed by the user in this text box. And then, of course, the standard set process is to take the parameter and store it in the field for that bean. Now, the other thing to note here is that the form has got a command button. It's a submit button. Its value, in other words, the text on the front of that button says View All Departments. And then the all-important action. Now, action could be the hard-coded name of the next view. Well, that's okay, but that means that every time that button is clicked, we will always end up at that next view. Sometimes, though, we might want to do some processing first, in which case, instead of putting a hard-coded name, we can use an expression value, which is actually a method within the managed bean, View All Depths. So if we come down to View All Depths, we can see that it's going to call some method within another class to obtain some values that are going to be stored in here, an array list. Now, we don't return that array list, we store it as a property so that the next view can obtain those by calling gdmAtStaffs. Now, having done that processing, we'll return, well, we've got a choice. We could either return the hard-coded name of the next view, or, as in this example, we can return some kind of string to represent the outcome of this execution. That will be checked against a file called faces.config, in which is defined a set of navigation rules. So here we have a navigation rule, and what we're saying is when we are moving from the index.xhtml view and we get an outcome of success, the control servlet is to display the alldepths.xhtml view. Now here we've only defined one navigation case, but it is possible within the one rule to have multiple navigation cases. So we can define different outcomes for this one view and specify for each of the different outcomes possibly a different view, a different destination. So that's what we're doing here. We're returning success, which means that we will now see the alldepths.xhtml view. And that's this fairly simple application. It's got in the dbase package a class for handling database interaction. And we've also got in the bean package some data transfer objects that will be used to store the data that comes out of the database that will then be passed to the managed bean and be used by the views. So what you'll need to do is to explore this application, make sure you understand how it's working, run it on your installation to make sure everything is working fine. Now, a quick word about statelessness and sessions. As you probably know, HTTP is a protocol that is stateless. In other words, all the information that is held on one request is treated in complete isolation from information in all other requests from the same client and indeed from other clients. There is no relationship between the different requests. But sometimes we want to store information from one request to make use of it in a later request. And this is where session management becomes helpful. For example, with an online banking system, you would only want to log in once. You don't want to have to provide your username and password on every single request. And so what we could do is check the login credentials on the first request, and if everything is okay, store those credentials in some kind of session variable. And thus state is retained between requests from the same client. So here we have an illustration of the various durations of different scopes. The application scope exists from beginning to end of the application. In other words, while the application is running, the application scope is in existence. The first client might then send in a request 1.1. And that will not only instantiate a request object within our framework, but also a session object. Client 2 might send in a request. Now this is a different request from a different client, and therefore not only is a second request object created, but also a second session. Client 3 might send in a request. That will create, again, another session. And when client 1 sends another request, that request is a different object from its first request and extends the life of the session for that client. There is a countdown, a timer on every session. It will vary according to the timing set within the server properties. And what will happen is, if there is no request received from the client within that countdown period, then the session will time out. And that's what is being illustrated with client 2. But client 1's session has not yet expired because a second request was sent in before the timeout occurred. Now, as time progresses, no further request has come in from client 1, and therefore its session has timed out. But client 3 has received another request, and therefore its session continues. A third request from client 3 will extend the session further, but in this case, that session has now been terminated programmatically by the application in response to request 3. For example, request 3 might actually be a logout request, in which case all those bits of information that have been stored in session 3 need to be deleted, so we should delete that object. And another request has now come in from client 1, but because client 1's session has timed out, that has caused a new session for client 1 to be created. If you're interested in finding out a bit more, here are some of the references. You should now proceed with the tutorial work which you can find on Blackboard.